Imagine waking up in a future where disease no longer exists. Where your immune system is smarter, faster, and more powerful than any drug. Where microscopic machines inside your body are fixing injuries before you even notice them. Where your brain is sharper, your organs are stronger, and your body never really ages. It sounds like the plot of a sci-fi movie. But it's not. This is real. This is nanotechnology. And it's not just going to change the world, it's going to change you. In today's video, we're going to take you on a journey through how nanotechnology will rewire the human body, down to the molecular level. We'll explore how scientists are using nanoscale robots to target cancer, repair organs, enhance the brain, and even reverse aging. By the end of this video, your definition of human biology will never be the same. Let's start at the root. What exactly is nanotechnology? Nanotech refers to the science of building and manipulating matter at the nanoscale, typically 1 to 100 nanometers. That's about 1/100,000th the width of a human hair. At that size, we're talking atoms and molecules. Why does that matter? Because at this level, physics and chemistry follow different rules. Atoms can be assembled with atomic precision, like programming Legos to build themselves. And if you can control matter at this scale, you can control biology. After all, life itself is built on molecular machines, enzymes, DNA, proteins. Now, we're learning how to engineer our own molecular machines. Machines that can travel inside your body, diagnose diseases, kill cancer cells, and even reconstruct damaged tissues from the inside out. The foundation of this revolution is already being laid. IBM developed a nanobot in 2019 capable of detecting DNA damage in cells. Caltech researchers created nanoscale, walking, robots that use DNA strands as legs. This is the beginning of programmable biology. And your body is the next frontier. Picture this. Inside your bloodstream, millions of autonomous nanobots are patrolling your body. Their mission? Eliminate pathogens. Remove toxins. Hunt down and destroy cancer cells. This isn't a theory, it's already begun. At the Chinese National Center for Nanoscience and Technology, researchers engineered nanorobots made from DNA that can cut off blood supply to tumors by delivering thrombin, causing the tumor to die off. The bots were tested on mice with aggressive cancer, and the results were remarkable. Tumor growth was suppressed, and no side effects were reported. Meanwhile, at Arizona State University, scientists are working on nanobots that can repair blood vessels after a stroke or heart attack, delivering targeted healing compounds directly to the damaged site. One of the most promising applications? Targeted drug delivery. Today's drugs often flood your entire system, causing side effects. Nanobots could deliver medicine to a single cell, no more, no less. In the future, these bots could even be equipped with sensors and logic gates, meaning they would only activate in the presence of specific chemical markers, like an early-stage tumor. This is healing with surgical precision, without a single incision. Now let's venture into the most complex system in your body, your brain. Over 86 billion neurons, trillions of synapses, and countless electrical signals firing every second. What if you could enhance it? Repair it? Even upgrade it? Enter neural nanobots. These bots could act as intermediaries between your neurons and the digital world. Elon Musk's Neuralink hopes to do this with implants, but Nanotech offers a less invasive path. Bots that flow through your bloodstream, cross the blood-brain barrier, and integrate with your neurons without surgery. In 2023, researchers at the University of California, San Diego created nanosensors capable of reading neurotransmitter activity in real time. These nanosensors could detect dopamine spikes, critical in understanding mood, learning, and mental health. But we're only scratching the surface. Nanobots could stimulate damaged neurons in patients with Parkinson's, Alzheimer's, or spinal injuries, essentially repairing or replacing damaged neural pathways. And what about enhancements? Imagine nanobots optimizing your brain chemistry to boost memory retention, enhance focus, or suppress anxiety on demand. You're not just thinking faster, you're thinking better. What happens when your body breaks down? When organs fail? When joints deteriorate? Right now, we rely on surgeries, transplants, and a ton of medication. But nanotech could change that completely. Imagine you have a failing liver. Instead of replacing it, nanobots enter your system, target the malfunctioning cells, repair DNA mutations, and regenerate tissue, all from inside. MIT researchers are developing nanoparticles that can regenerate heart tissue after a heart attack. These particles deliver RNA instructions to promote cell growth and reduce scar formation. In bones and joints, nanobots could be used to reinforce skeletal structure or even stimulate the growth of cartilage. A study from the University of Michigan used nanomaterials to regrow knee cartilage in rabbits, completely reversing joint damage. And when it comes to muscles, athletes could someday use nanotechnology to stimulate growth, reduce inflammation, and accelerate healing far beyond what's naturally possible. We're entering an age where recovery time might be measured in hours, not weeks. Now imagine this: a synthetic immune system. One that never forgets, never sleeps, and evolves in real time. Natural immunity relies on trial and error learning. But with nanobots, you could pre-program responses to any pathogen. Nanobots could scan your body 24/7, identify foreign invaders, and eliminate them before symptoms emerge. These bots could also act as archivists, logging every pathogen they've encountered, sharing data with other nanobots in your system, or even uploading insights to a cloud-based medical AI. Think of it as a personal, evolving antivirus system for your body. One breakthrough study from China showed nanobots camouflaged in red blood cell membranes could detect and trap bacterial toxins in the bloodstream, neutralizing sepsis. Eventually, you could download immune upgrades, just like you update your phone. Now let's go full sci-fi. Because nanotechnology might not just heal your body, it could rewind it. Aging, at its core, is molecular decay. DNA breaks down, proteins misfold, mitochondria fail, and senescent cells clog up your tissues. But what if nanobots could go in, identify damaged components, and replace them? George Church, Harvard geneticist and synthetic biology pioneer, believes age reversal will come from gene editing and nanotech combined. He's already backing companies exploring this space. Senolytic nanobots could seek out and destroy zombie cells, those senescent, inflammation-causing cells that build up as you age. Other bots could deliver CRISPR-based gene edits to repair mutations that accumulate over decades. Telomeres, the protective caps on your DNA that shrink with age, could be rebuilt with RNA nanobots that stimulate telomerase production. And mitochondria, your cellular engines, could be repaired or even replaced with synthetic nanomachines that produce ATP more efficiently. We're not just talking about living longer. We're talking about staying young while doing it. We are standing at the edge of a new biological era. One where biology is programmable. One where healing happens from the inside. And where being human doesn't mean being limited by nature. Nanotechnology could eliminate diseases, enhance our brains, rebuild our organs, and even stop the clock on aging. But with great power comes great responsibility. Who controls this tech? Who gets access to it? And what happens when the line between human and machine blurs completely? These are the questions we'll need to answer, because the future isn't waiting. It's already under your skin. If this blew your mind, smash that like button, subscribe to Futuristic Edge, and turn on the bell for more mind-bending content every week. Because here, we don't just talk about the future. We explore the edge of it.